welcome to week 6. I hope all of you guys have made it through your other classes okay and have settled in with this class. I am reviewing some of the surveys that you guys can fill out as soon as you come in at the front of eCollege here, as soon as you log into the class. And I'm still getting a lot of responses saying that they're unclear of what to do for each week, or it's still confusing. If you are still confused, I have not received email from you to better guide you through your assignments. Based on the syllabus, there is assignments for each week. I am considering dropping that group project and actually having an individual project instead of group projects. Some students are further off than some, and some I think are still unclear of what they should be doing in the class. Most of you guys are passing, so just email me and let me know what issues you actually have so I can help you through them. Alright, week 6, the system unit. Last week we talked about system software. Now we're actually going to talk about the units that the system software runs on and ports and those type of things. This will be a quick run through just as last week, but just to make sure that we still have that interactive piece for this class, I'll discuss the PowerPoint in a little bit more depth than what you probably would find in the book. Alright, introduction. Usually with system units, you look for speed, capacity, and flexibility. Back in the day, the older mainframe computers, they were really small. It was really hard to get them fast. They were still in the kilobytes and megahertz, not gigahertz like they are now. Most cordless phones you have are already in 2.4 gigahertz. So just think of some of your not mobile phones, but cordless phones in your house were faster than some of these older computers. System unit types. You have desktops, media center systems, you have netbook systems, you have tablet PC systems, handheld computers, and then you have system units. System units compose of all of these different types. You have your desktop, media, notebook, tablet, and handheld. Let's see if I can get me a pointer here. These are just the basic type of systems. They don't have servers in here, but they usually fall under desktop systems or server grade system units, which is not listed in here, but that is another type of system unit. Alright, the system unit, or the system chassis, you have your system board, which we call it motherboard, microprocessor, which is your CPU here. Most people here call it CPU, central processing unit. Everything goes through here that runs on your system. Then you have your memory, which is another term, RAM, random access memory. This right here randomly accesses things from your computer and stores them into these individual chips anywhere on them. It breaks down into binary and it transfers throughout your motherboard here. Then you have your bus lines and expansion slots. Let's see if I can get in here real quick. Your expansion slots would be these guys right here. So anytime you add a video card or add a sound card or any other type of card that you can get out of the store, you can actually add it into these slots here, and these are called PCI slots that they actually showing in here. So just kind of a rundown of the basic units, which you've seen in chapter 1. They've used the same similar picture to depict that. Electrical data instructions. two state systems of binary systems. Off on, you have your bits and your bytes. Pretty much whenever you turn a computer off, that's off, and when you turn it on, you can think of that aspect. But computers are pretty much based on zeros and ones. There's no assignments that has something like that, but it would depict something like this. I'm writing these in 4-octave right here. Oh, I can't write off the screen there. I'm writing these in 4-octave because they're usually read in 4-octave. It helps break down the actual binary a lot faster. And those compose into bits and then turns into bytes, and then megabytes, and then gigabytes, and then terabytes. Your character coding scheme right here. This is your decimal, binary, and hex. All these are representations. If you want to write down a 1, this would be the binary representation. This would be the hex representation. This would also be the decimal representation, with of course decimals in the front of those. Remember ASCII, American Standard Code for Information Exchange, EBCDIC, Extended Binary Code Decimal Interchange Code, which your actual binary coding has another extended chart, and that's where the smiley faces and all those other things come from within typing. Unicode handles languages without large numbers of characters. Example for Unicode, some databases actually store Unicode within their system. Alright, we covered the system board a little bit, but remember, this is your motherboard here as a whole. These are your PCI slots. These are your RAM slots. This is where your CPU goes. And this is your bus line, which everything kind of goes through there. The faster your bus is, the faster your data is going to transfer. Just think, if you have a fast bus, then you can go really fast. If you have a really slow bus that's cheap and out of date, it's going to go really slow and always break down. Good analogy. Microprocessor chips. These are the tiny chips, very, very tiny. I think in a class live session a couple of weeks ago, probably week 2, we actually talked about microcontrollers. And there's all sorts of microcontrollers. You can read this chapter a little bit more, research more on microcontrollers. If anybody's heard of Arduino, Atmel, PICs, microcontrollers, those type of microcontrollers will be explored, and they're in a lot of different things, like your microwave, your cars, your keychains, your cell phones, believe it or not. It actually is in a lot of things. This summer we will teach a class here at Texas A&M Commerce on Intro to Microcontrollers. It's a little bit more advanced. You have to have a little bit of C++ knowledge and a little bit of assembly knowledge and binary. But if you have that knowledge, and if you've just taken this class to kind of push your GPA up, or just learn more about Office, you might want to take the class if you're interested in microcontrollers. Microprocessor chips. We have a Core 2 Quad, Core 2 Extreme, Xeon, Athlon 64, and a lot of people don't know the difference between these multi-cores. You won't really see any 32-bit computers anymore because it only can address so much memory. It only can address physically about 3 gigs of memory. 64 gig can address up to 256 gigs of memory. So the math is completely different. Doesn't really tell you much on the descriptions over here. But just remember, 32s can only address up to 3 gigabytes of memory, and that's your RAM that you put in your computer, the random access memory. Or you can get a 64 that would go up to 256. Specialty processors. If you've ever went to a high security place where they actually swipe their cards into some kind of machine and it opens the door, those cards are kind of a a type of specialty processor. Sometimes I wouldn't even consider it a processor. It's pretty much copper wound up with a specific number embedded into that copper and allow you in. The same thing with RFID tags. Very, very, very complex, old technology, but it's being used more and more now. It's like coming back and more secure. Most of your credit cards, believe it or not, if they have the Bing logo on the back, you can actually go touch that to some ATM machines, some swipe card machines in the store, and it automatically pulls that information off of your card. As well as a hacker could do the same thing, walk up to you with an RFID reader and just swipe your wallet and get all of your credit card numbers. So it kind of works both ways there. Alright, we're talking about memory. Types of memory: random access memory, programs and data are the main things that actually use that. ROMs are more like when you go buy a DVD from the store, it's a fixed startup instruction. So it's fixed and you can't add more to that. You're just stuck. It's read-only memory. You can only read it. Random access memory allows you to access that memory. Flash is a type of flexible startup instructions. It allows you to store multiple things on that, such as anything you can store in RAM, anything you can store in ROM, and anything you can store on pretty much anything known to man you can store on Flash. It comes in all different types of formats. The SD card you put in there, that's a type of Flash. The USB flash drives you actually have, they're a type of Flash. They're just everywhere. RAM. RAM, it caches your memory within your computer. If you access something, it stores a piece, remember, in each one of these blocks here. And it can be stretched over all these blocks. These blocks look really small, but they can address a lot, possibly. I'm not sure what size the stick is. Let's say this was a 4 gig stick. It would have a ton of space to store things over here, spanned over these 4 chips. And most of the time, they have chips on the back. The types of RAM that you'll see today is DRAM, SDRAM, DDR-RAM, and Direct RD RAM. The Direct RD RAM is not well known anymore. It's still around, but it's not well known. Most of the time you're going to run into DDR, RD RAM, and SDRAM. ROM, remember, read-only memory. It's a chip or a DVD that's non-writable once you write it. A DVD becomes a ROM once you write everything on it, because you cannot change things on there. Speaking this time right here, it cannot be changed by the user. A CPU can be read or retrieve data and programs, but the computer cannot write to it. It contains specific instructions. It's only going to do one thing, not going to do anything else. Flash is a type of flash memory. Its feature is RAM and ROM. You can store stuff onto a flash drive and make it where it's not deleted or not altered, but you can also make it RAM, where you can always access this thing and put things onto it. So that's where you get the actual flexibility from RAM, Flash. Expansion slots, we talked about earlier, goes into those little PCI slots here that they have a picture of. And they're actually plugging a video card into this. This is a common use for it. Pretty much video cards now. Everything else is built on board, such as your sound and your Ethernet. Commonly used expansion slots: graphics cards, sound cards, network interface cards, aka NICs, wireless network cards, PCI cards, and express cards, and TV tuners, which a lot of these things, TV tuners, most of the time are built in. They're not even really that widely used, but that's probably why it's not in the bolded color there, because some people put it in there, but it's not required anymore. Nobody really cares about TV tuners for computers. And they're talking about TV tuners. TV tuners, pretty much you hook your cable into your computer, and you can treat your computer just like a DVR. plug and play. If you've ever noticed, anytime you stick something into your computer, a little window comes on the side there and says that you've just plugged something in or are getting ready to install. That means plug and play. That means it's going to go retrieve your drivers and have it ready for you. So whatever you plugged in, you can use it without any intervention by yourself. Bus lines. Remember, bus lines are the bus line from your point of entry, which is your bus chip, to your CPU, to your RAM. That's a communication circle. And within that circle, it goes to your PCI slots and every other chip on your board. That's something that is very useful and very complicated on how it works. It has to handle fast traffic as well, because if not, then your computer's going to run slow. Expansion buses. Most people, you can buy PCI cards, and those are in the expansion slots there. You can buy USB cards that'll help out with your speed. Fireware boxes that'll help out with speed. SATA, Serial Advanced Technology Attachment, which is what most hard drives are right now. So instead of putting all that weight and speed and time on your board, you're actually putting it on the card or the piece of equipment that you're putting on there. Ports, you have your standard ports, legacy ports, specialized ports. Standard ports, VGA, USB, FireWire, Ethernet. Legacy ports. These are the old ports that you probably won't find on a computer anymore. Serial port, parallel port, keyboard and mouse port. They used to call them PS2 ports. Infrared data association port, IRDA, which I haven't even seen those on computers in 20 odd years. And then you have your game port, which, you know, that's been replaced by the USB. Specialized port, music instruments, MIDI. Most of your computers have, let's see, I think it's green, pink, and blue. Your blue is usually considered your MIDI port on your computer. Some people actually have MIDI cards that plug in special into their computer. But the blue port will act as a MIDI, when another name for it is line in. The Sony and Philips thing is pretty proprietary, so it's not really useful. But the high definition multimedia interface is the HDMI port, which that's where you get all of your high def images from. Most of your new monitors have HDMI ports. Most of your video games send data over through HDMI, so it's a very well known port. Your different cables here. You have your USB. Let's see if I can get up in here. Alright, you have your USB here. You have your DVI. You have your FireWire. And remember, you have to be very careful about these because you can plug FireWire in wrong. You have your Ethernet port, as well as your telephone port. Ethernet ports are also called RJ45. And your phone ports are usually called RJ11s. So if anybody ever tells you RJ11 or 45, you know what both of those are. Power supplies. Power supplies is something that constantly powers your computer, regulates bad electricity and turns it into good electricity for your computer, and gives your computer and components the exact power they need. The same thing works for a laptop power supply. Careers in IT. There's not much money in kind of computer support using these things because it's so well known by individuals. Most people can almost work on their own computers now without messing it up. A really cool thing was look into the future. They have wearable computers, which they already have. They're pretty awesome, kind of expensive. Send and receive email while jogging. Of course, you have that because you send it from your cell phone. And now with Siri, with the iPhone 4S, you can actually talk and it types it out and sends it for you. Maintain your personal schedule book. Once again, Siri, with the iPhone 4S, you can set an appointment and time just through your voice. Remember the names of people at a party. That is more, I'm not sure how it would do that. Maybe Siri would be able to do that too if you tell everybody you meet, hey, talking to my phone, I want to remember who you are, kind of thing, but I'm not sure. So, this is the end of the chapter. If you have any questions, be sure to send me an email. And if you have any questions on the midterm, send me an email about that as well. It should be fairly easy. It is next week, and it'll just be over most of the chapter quizzes that you have completed. So, nothing major there. Alright, until next time.